Hey guys, today we are actually going to be doing like a Lewis structure of a compound. Okay, so the compound given to you is IF5. So iodine, literally pentafluoride, right? So you're asked to computate and predict the Lewis structure, molecular structure, so like with the bond angles, and the expected hybrid orbital on the central atom alongside the polarity. So the way that I approach a problem like this is, first I think of my central atom, which is iodine. Iodine has 7 valence electrons. It's an, right, 2, 3. Here is my iodine, and I think of my fluorines. So you have 5 times a fluorine. 1, 2, right? Okay. Now the first thing you do is you lay out your central atom, which is iodine. Here is your iodine. Iodine, and the way I think of this right now is I think that there's 5 fluorines, which means that technically 5 of these, let's say, are going to break off and they're going to get excited and they're going to go bond with fluorines. And that's going to leave you with 1 lone pair. So when you're predicting the shapes, you have to account for this lone pair that is going to cause the shape of the molecule to change. Like let's say I had a molecule that was linear, but then I had a molecule that's bent. This would be because this lone pair. So we have to always account for the lone pair that'll change the molecular and Lewis structure of the atom. Of the compound. So I know that because I have 5 fluorines, there's going to be a lone pair here. So I might as well just place my lone pair already and finish creating the covalent structure. Okay. So now I have 5 fluorines. So I'm going to put a fluorine here. 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 And I'm going to put a fluorine here. The first thing I'm going to do now is put all my electrons. So every single one of these fluorines is going to have 6 electrons surrounding it and a shared pair with an iodine. With iodine, I should say. Okay, so now I have to predict the shape. Well, one, we know that it can be an octahedral. We know that it can be anything that is non-polar because one end is going to be all fluorine and one end is going to be this lone pair. You have to think about the symmetry. It's not symmetrical because one end has a lone pair from iodine. So we know that it's going to be non-polar. We can predict the hybridization. We know that iodine is surrounded by, let's count, 1, 2, 3, 4, 5, 6 effective pairs, which means our hybridization is going to be D2sp3. 3 orbitals for p plus 1 s is 4 plus 2d gives you 6 effective pairs. Once you've narrowed it down to here, it's pretty easy to predict the shape because your options are now limited because not every shape has these characteristics, right? So the shape of IF5 is going to be a square pyramid. And the bond angle is approximately 90 degrees and it is polar.